Voyager 1 has sent strange signals back to Earth that NASA scientists simply cannot explain. Together with its identical twin, the aging space probe has significantly shaped our understanding of the outer solar system and has even ventured into interstellar space. But what has happened to Voyager 1 in the vastness of space? Have we finally received a response to the Voyager Golden Records? Or has Voyager 1 been intercepted by an alien civilization? Stay tuned until the end and find out with us. 25 and 20 billion kilometers. These are the almost unimaginable distances that NASA's Voyager 1 and 2 space probes have traveled between themselves and the Sun since their launch in 1977. No other man-made object has ever ventured so far into the depths of space, and it's only natural that this journey into interstellar space has yielded data that is absolutely unique. However, we must not forget that Voyager 1 and 2 have also made a decisive contribution to shedding much more light on our planetary neighborhood. In fact, what is now considered humanity's furthest outpost was not originally intended to break through the boundaries of the solar system, but merely to provide new insights into the outer planets, which were largely unexplored at the time. And to say that the probe duo mastered this task would be a gross understatement. Voyager 1 and 2 collected measurement data and images during their planetary day tours, many of which are still unique to this day. This means that Voyager 2 remains the only space probe to have visited all 4 outer members of our planetary system. At the same time, the Flying Old-Timer also became the first and only probe to visit 4 planets. Voyager 2 still has exclusive rights to the journey to Uranus and Neptune, which is why we still owe practically everything we know about these remote ice giants to it. This includes knowledge about the extraordinary quadrupolar magnetic field of the 2 celestial bodies, as well as the fact that the comparatively small planetary cores are surrounded by a massive ice shell. But when it comes to moons, no other space probe can hold a candle to the NASA veterans. No other mission has discovered as many new satellites as the Voyager probes. All in all, the duo discovered 3 moons of Jupiter, 4 Saturnine moons, 11 satellites of Uranus, and 6 Neptune companions. One of these, Jupiter's moon, Io, even became the first celestial body other than Earth on which active volcanoes were detected. And as if this discovery wasn't exciting enough, Voyager 1 also became the first space probe to observe lightning on another planet. More precisely, in Jupiter's gigantic atmosphere. Voyager 2 in turn provided us with spectacular insights into the ring systems of Jupiter, Uranus, and Neptune. And last but not least, we also owe the first indications that a vast ocean lies dormant beneath the icy surface of Jupiter's moon Europa, and thus a potential underwater world in which extraterrestrial life may already have developed. How interstellar space amazes researchers. There is no question that all the records and discoveries made by the Voyager probes in our planetary neighborhood were revolutionary. However, there is also no question that all these milestones are now a few days behind us and that the spacecraft are now making headlines for entirely different reasons. As mentioned above, these aging space pioneers have been traveling through interstellar space for several years now and have made some equally astonishing discoveries. To put these into perspective, however, we need to briefly review a few basic facts. According to these, the Sun is not a rigid, immobile star that simply shines away, but rather a rapid furnace that races through space at a speed of 725,000 kmh. Dynamic magnetic field lines extend around our central star along, which plasma streams known as solar winds escape continuously. These solar winds penetrate our entire home system and eventually reach the interstellar medium. The mixture of particles, magnetic fields, and radiation that was ejected into space during and after the Big Bang still fills the space between the stars today. However, the solar winds in the interstellar medium do not mix evenly with each other. They behave more like oil and water. As a result, the solar winds form a bubble within the medium called the heliosphere. In simple terms, this is a solar shield that protects everything inside it from most of the dangerous cosmic radiation. The Voyager data show that the heliosphere extends about 18 billion kilometers around the Sun, and its outermost region, the helipause, ultimately marks a boundary with interstellar space. When Voyager 1 entered this wondrous border region in 2012, it immediately caused astonishment among experts. The interstellar magnetic field was actually 2 to 3 times stronger than previously expected, which in turn means that the pressure exerted by the interstellar particles on the helipause is up to 10 times stronger than thought. At the same time, however, the insight gained by Voyager 1 also had a major drawback. It was incomplete. The instrument used to measure the plasma temperature has been broken since the 1980s. Fortunately, this was not the case for its counterpart on board Voyager 2. In light of this, Voyager 2's arrival in interstellar space 6 years later proved to be even more revealing. Since then, it has become clear what happens when an object comes into close contact with a helipause. The surrounding plasma slows down, becomes denser, and at the same time hotter. However, this plasma is so extremely thin and uneven in its composition that the temperatures measured around Voyager 2 were surprisingly low. The exact opposite was true of the interstellar medium itself, however, which turned out to be much hotter than expected with temperatures of almost 30,000 degrees. In addition, Voyager 2 showed that the plasma from both sides of the helipause crosses over into the other area in the form of a cosmic stream of low-energy particles that spills 160 million kilometers into the helipause. Another thing that amazed the experts was what the probes observed as they approached the helipause. While Voyager 1 had entered a relatively static area at a distance of 1.3 billion kilometers where the solar wind had slowed down rapidly, Voyager 2 crossed a region that was significantly different from its static counterpart. Patrick Kahn, a program scientist at NASA headquarters, described this as quite strange and emphasized the importance of collecting even more extensive data sets in the future. However, this applies not only to the differences revealed by the probes, but also to the heliosphere itself. After all, it's a gigantic structure that has only been explored in 2 places so far. In fact, we don't even know what shape our sunshield actually has. It could be spherical, resemble a croissant, or be adorned with a kind of comet tail. The mysterious message from Voyager 1. The last thing you want in the depths of interstellar space is a probe that suddenly goes haywire. But unfortunately, astronomical reality is not a wish list. These days, you can almost set your clock by the technical complications that Voyager 1 and 2 experience. And that was exactly the case again a few years ago. Specifically, Voyager 1 began sending a chaotic jumble of data back to Earth, providing researchers with signals that simply didn't make any sense. After this incident made the rounds, it didn't take long for the online community to come up with explanations. And as usual, they didn't shy away from rather surprising theories. From an extraterrestrial civilization that may have intercepted the probe to aliens who reprogrammed Voyager 1 and sent it back to us with a declaration of war, the speculations were as numerous as they were outlandish. As far as we know, no galactic war has yet plunged Earth into chaos. So what happened? Well, at first it looked as if the chaotic telemetry data had been generated completely at random. The data from the attitude articulation and control system indicated a system failure, and yet the probe seemed to be functioning completely normally otherwise. This position control system is responsible, among other things, for precisely aligning Voyager's main antenna with Earth because this is the only way to maintain communication over such a gigantic distance. So it was all the more astonishing that despite the faulty AACS data, the scientific instruments continued to send data as normal, and Voyager also continued to respond to commands from Earth. The strength of the signal received also remained unchanged, which could only mean that the main antenna was still correctly aligned with Earth. To everyone's relief, after weeks of guesswork, NASA finally managed to track down the error and solve the mystery of Voyager's mysterious data. First, NASA engineers determined that the attitude control system was indeed working correctly, with one small but crucial caveat. It was attempting to send telemetry data to Earth via an onboard computer that had been out of service for years. As a result, the information arrived as nothing more than garbled data garbage, causing considerable confusion in control centers. NASA then used the radio antennas of the Deep Space Network to instruct the AACS to forward the data back to the correct functioning onboard computer. This was successful, and the scientists were once again able to enjoy clear and complete telemetry data. Finally, however, it remained to be clarified why the attitude control system had resorted to the long-disused computer in the first place. Ultimately, it turned out that the error had probably been lurking in the flight data subsystem, a computer that packs the data into packets for transmission to Earth. As it turned out, around 3% of the memory was defective, and those responsible suspect that a single memory chip was the cause. This could have been damaged by a high-energy particle from space or simply worn out after decades of operation. And now you're welcome to wear out the subscribe button with your clicks. Just press the thumbs up and subscribe to never miss a video from us.